function. I want you to make sure that you see an interval. Okay, so right here I have an interval. I got a pen here, is from 0 to 5. Okay, so you're telling me, is this function continuous or discontinuous on the interval 0 to 5? First of all, if there's algebra to do, I want you to do it. So I'm going to look at, this is a fraction, so I know that if I do x minus 4, it cannot equal 0. Add 4 to both sides, x cannot equal 4. Okay, so that means there is an asymptote, a vertical asymptote at x equals 4. So this kind of goes into what we were talking about before with the rational functions, because that's what this is. So there's a vertical asymptote at x equals 4. If that is within the interval, that means I'm going to pick up my pencil and there's a hole in the graph. So I know that this function is discontinuous. Okay? This is a discontinuous function on that interval. All right, so let's look at this again, the same function. I've already done the work, and I'm talking about the interval -2 to 2. Well, if I only know the only hole in this graph or the only vertical asymptote is at x equals 4, that means everywhere else it's continuous. So the only thing I know is x cannot equal 4. So I know on that interval that it's continuous. Okay, so I'm going to bring up the graph. So I've already graphed all these, and yeah, it should be. Yeah, you're right. So here's the graph. Yeah, that's backwards, hon. So here's the graph. If you look at it, here's my vertical asymptote at x equals 4 right here, right here. So when I looked at the interval 0 to 5, I did, if I was drawing this graph, I would pick up my pencil in that interval, so it's discontinuous. On the interval from -2 to 2, okay, I'm not picking my pencil up because it's continuous there. So you could have the same function, and based on whatever you're looking at, whatever interval, you could have it to be continuous or discontinuous, and it's the same function. Okay, really, that's all there is to it. It's kind of an easy concept. All right, let's try this next one. I've got the same function twice. I graphed it, 1 over radical 2x minus 7. So I graphed that already. So that's right here. As you can see, it looks like right in here, there's a vertical asymptote. So, and then it looks continuous over here. So we just got to figure out where that is. So there's some algebra to do. So I'm going to go back to here. So the first thing I do is I take my my radical and I look at it and say, oh, it cannot, it's got to be 2x minus 7 has to be greater than 0. I cannot say greater than or equal to 0 because it's in a denominator. Add 7 to both sides, so 2x is greater than 7. Divide by 2, x is greater than 7 halves. So 7 halves, if you think about it, I'm like, what is that? Well, that's 3.5. All right. So basically, I got to know where that is. So if this is right here, it has to be greater than 7 halves. It has to be greater than three halves. If I look within this interval here, I see, oh, well, 3 halves or 7 halves happens before 4. This is continuous on this interval. Here, 3.5, this falls within that, so it's discontinuous on this interval, even though it's the same function. So as we look at this, usually I do this in class. I said, okay, this is 1, 2, 3.5 right here. So right here, this has a vertical asymptote at 3.5. So when the interval was between 4 and 5, I was over here, so I didn't pick up my pencil. The other interval was between 3 and 4. It didn't even exist over here, so it's considered discontinuous because you have to pick your pencil up to draw. Okay? Now let's look at some trig functions. This causes people angst, first of all, because they want to graph everything, which is fine, but then they got to play around with the interval, with the how to look at it. So they're asking you from negative pi over 2 to pi over 2. So the first thing I want to do is figure out with some algebra. So I'm going to do 2 sine of x cannot equal 0. Divide by both sides, sine of x cannot equal 0, right? So then I got to figure out where is the sine of x equal to 0? Okay, so I'm thinking the sine of x, I know that the sine of 0 is 0. I know this. I have it memorized. I know that the sine of 0 is 0. I see that 0 is between negative pi over 2 or pi over 2. So you can think about it. I'm going from negative 90 to positive 90. If you're doing that, 0 is in between. So this is discontinuous. Now, this bothers people because they can't really picture this. So I spent time playing around with this. So lots of times when I put this on a quiz or whatever, what takes the most time is kind of like you have to show me the algebra, but then trying to check on the graph. So I'll show you what the graph looks like. So I did graph this. I actually went from negative pi to pi, and I had it count by pi over 4. So here's pi over 4, pi over 2, 3 pi over 4, and 4 pi over 4. So right here, all right, is pi over 4, and negative pi over 4 would be here. As you can see, between negative pi over 4 and pi over 4, there's a hole in the graph. So it's discontinuous in that function. Now, to make these look good, you don't want to just let the calculator do this. If you do, you're just going to see a lot of wavy lines. It's not helpful. So when you hit this, you're going to hit menu, you're going to do Windows Zoom, and then you're going to play with your window settings. Notice I went from negative pi over pi to pi, and then I counted by pi over 4. When I do that, it's a lot easier to see where I'm looking on the graph, because if you don't do that, it's very difficult to see or check the work that you've done. Okay, so when I come back here, I see that it's discontinuous. I did the algebra because I know the sine of 0 is 0 in that in that interval. So I have to pick up my pencil, and that's where it doesn't exist, and so that's discontinuous on that interval. The next one I'm doing is 1 over cosine. Again, I graphed this. I changed the window. I did all this. And I'm looking on the window from negative pi over 4 to positive pi over 4. So I look at this and say, okay, cosine of x cannot equal 0. And then I think about it, when is the cosine of x 0? And I know that the cosine of x is 0 is when it's like the cosine of pi over 2. I know is 0. Okay, so this one here is negative pi over 4 to pi over 4, which is 45. As you can see, this is the cosine of 90 equals 0, or cosine of pi over 2. That's not within that interval, so this is continuous. Again, this causes a little bit of angst if you did not memorize your table, to memorize, okay, what are these values, so that you're not relying solely on the graph, right? So let's look at the graph of number 6. So I actually went through, changed the window so I could see what's going on, counted by pi over 4. As you can see, from negative pi over 4, which would be right here, to pi over 4, it's a continuous function. It becomes discontinuous over here at pi over 2, okay, because that's where cosine is 0, and negative pi over 2 right here, because that's where cosine is 0. So again, I checked with my graph. I made it look nice so that I could see what's going on, to make sure I can talk about continuous and discontinuous. Okay. All right. So that's how you do that, and that's what the assignment's going to be like. There's going to be a video for that, but it's as simple as that. All right. The only thing that causes a little issue is sometimes trig functions. Now, 7 and 8 are a little bit different, and we're talking about find k so the function is continuous on a given interval. I want you to think of the piecewise functions we talked about earlier this year, okay? And as you see below, they're both piecewise functions. And remember when we had piecewise functions, that if we were going to graph it where it was continuous, where I didn't pick up my pencil, my y's had to match at both pieces for it to be the same. So for example, I'm just going to do something. Here I have a graph here, and then I have a graph going this way. I would say it's discontinuous right here, whatever this value is, because I picked up my pencil. It doesn't exist here, but it is here. In order for us to make this continuous, we basically took this and you could actually move it up. And if I moved it up and made it here, then I wouldn't pick up my pencil. My y's matched at that point and it would be continuous. So you're basically shifting it up to make it from a discontinuous to a continuous function. So what I want you to remember is, okay, I got to get my y's to match. So I have a function here, y equals kx and y equals 2x squared. The breaking point is at x is 3. So basically, I want to know at the point 3 something, whatever it is, the y's have to match so that I can make this continuous on that interval. Okay, so what I do is I basically take this piece down here, throw in the x, so I have 2 times 3 squared, okay, has to equal kx. And in the x spot here, okay, you can put the 3 because that's where the breaking point is. So I have 2 times 9, or 18, has to equal 3k. If I divide by 3, k has to equal 6. So I'm saying that this should be 6x. If I plug 3 into both of that, see here, I'll plug a 3 in here, I would get the point 318. Even though that's not in that piece, it goes all the way up to that. If I plug the point 3 here, which it is in there, I get 3 squared, or 9 times 2, that's the point 318. So even though this is an open circle and this is a closed circle, because this fills that in, I have now made that function continuous. Okay? Now I'm going to use a 3 again, just because I had it. So I have this piecewise function where I have y equals this ugly function here, and then I have y equals k. And I want to make sure that I have the same k value so that they would be a continuous function. So the first thing I'm going to do is actually try to, the way this goes is if I stuck a 3 in here, it'd be it's undetermined, it doesn't exist. So what I'm going to do is factor the top. So I'm going to do 6x cubed. If I factor that out, I have x minus 3 in the numerator all over x minus 3. And we're going to do this with limits. So I factored and got rid of that. So I can really look at the first one as 6x cubed. I get it doesn't exist at 3, but that helps us a lot with the algebra. So I'm going to say that piece is 6x cubed. And I'm going to take that and I'm going to basically have that equal k. Where do they want me to do that? Check that out. It just happens to be 3, so I stick a 3 in there. So 6 times 3 cubed has to equal k, which is, if you put that in your calculator, is 162. So k has to equal 162, that if I plugged a 3 in this one in the numerator and the denominator, that, not the numerator, excuse me, that if I plugged it in the top function and the bottom function, my y value would be 162, and then that would make it continuous. Okay, so that is a little bit of something I wanted to show you because they might ask you how to make it continuous. Just put your x in at your breaking point and make your y's equal, and that will make your function continuous. So what I'm going to do right now is bring this up. I'm going to stop the recording.